Good evening. I welcome you all for another presentation on our control system subject. In today's presentation, I will explain you about few important examples on RH criterion, that is Routh-Hurwitz criterion. So, by using this RH criterion, how the stability of the given system can be commented or can be justified, that we will see with some examples. So, in today's presentation, we are discussing our lecture number 56. Okay, we will see some examples. So, let us consider the first example as this one. Let us just say equation s power 4 plus 8 into s cube plus it is 18 into s square plus and then 16 times s plus 5 equal to 0. This is the given polynomial. Comment on the stability of the system. Comment on the stability of the system. This is the thing. Comment on the stability of the system using RH criteria. Using RH criteria. This is the given problem. Let us see. So, this is the one polynomial which is given s power 4 into s cube into 18s square plus 16s plus 5 equal to 0. This is nothing but a characteristic equation. So, for this characteristic equation, we need to find out the stability. So, what shall we need to do now? So, now I will explain you the solution part of it. Let us form a Routh table first. So, if you see the solution part, we have to start with, we must form the Routh array. It is called Routh array. Routh array. What is the Routh array? That will be formed like this. Let us from this given characteristic equation, you can form this Routh array like this. Take s power 4 starting as s power 4, then it is s cube, then it is s square, s power 1 and s power 0. Likewise, you need to take the s values actually, right? So, it s power 4, s cube, s square and then s power 1, s power 0. Clear? Now you draw a line like this. Now, consider the coefficients of these various s values. So, let us take s power 4. What is the coefficient of s power 4? It is 1. So, let us take 1 and ignore the next one, means the alternative coefficients you must write. So, s power 4 coefficient is 1, then you ignore the s cube, go for the alternative, that is 18. So, write 18 here and then ignore the next one, write the next coefficient, that is 5. So, you must write like this, s power 4 coefficient is 1, then ignore the next one, note down the alternative, that is 18 and ignore the next one and write it is s power 0 in fact, right, 5. And similarly s cube, right, the s cube coefficient also, this row also, that is s cube coefficient is 8, this is 8 and ignore the 18, the next is the 16 actually, right. So, s cube coefficient is 8 here, therefore ignore the next one and then consider the next alternative, means that is 16, and afterwards you have to ignore, or otherwise the next value becomes 0. Therefore these two rows must be considered from the given characteristic equation. Now for the s square, you should not consider from this equation, no. So these s square onwards, s square and then s power 1, s power 0, these values, so here the values will be obtained from these two rows only. Now let us see carefully here. In order to find out here the value of s square, then you need to do that 8 into 18, right, minus 1 into 16 by 8. I will write here. So here for this s square, the value will be like this, 1 into 16. It is plus sign actually. You consider first this 1 into 16. Then 8 into 18, this you must consider as minus. That is 1 into 16, 1 into 16, right, minus, right, 8 into 18. Is it not? 8 into 18. Or otherwise, you can do one thing. For our simple calculations, you can do one thing actually. So here 8 and 16, 0 will be there in the second row. Then you can cancel as 8 ones are 8, 8 twos are 16. Therefore, you can write 1, 2, 0 also. You can write, clear? You can write like this also, nothing wrong in that. Because if all these coefficients are okay, multiples of one common element, then you can take the common element actually. So here 8 ones are 8, 8 twos are 16, and then it is 0 actually. Then now 1 into 2, it is plus, and then 1 into 18 actually. Clear? 1 into 18 you can write. Is it not? Is it not? So 1 into okay. So let us, I will write clearly again this. I will write clearly what you are writing. So 1, 18, 5, and it is 1, 2, 0. 8 ones are 8 twos are. Therefore this comes. So you have to consider this one actually. 1 into 18, this is plus, 1 into 2, this you have to consider as minus. This you need to consider plus, not 1 into 2. 1 into 18 means that here 1 into 18, that is okay, minus 1 into 2 whole by 1. This you have to write. Clear? 1 into 18, this one you have to consider. 1 into 18, 18 minus, if you take the arrow mark, down arrow mark, minus will be considered. So minus 1 into 2 is 2. Therefore 18 ones are, 18 into 1 is 18. 18 minus 2, it is 16. 16 by 1, 16. So you will get here the 16. So you will get here 16. So here the value is 16. You will get 16. Clear? So that is how we have to consider. Right? That is how we have to consider. So upward direction, going upward direction, take the positive sign. Coming to the downward arrow, take the minus sign. That's it. Now, this value is we have obtained. This is for s square what we are calculating. Now, what is the value here now? Under this particular column, what is the value of here? In order to find out the value of the second value in this s square row, then you have to ignore this particular actually. You need not to consider this. Now consider that 1 into 5 like this. Like this you have to consider 1 into 5 here. 1 into 5 minus 1 into 0. This you have to consider. Always consider the first element with respect to the alternative actually. So it is 1 into 5, 5 minus because for down arrow mark consider minus n. 1 into 0, 0 by again 1 only. 1 only means finally what you will get, 1 into 5, 5 minus 5, 1 into 0, 0 means 5 minus 0 by 1 means obviously you will get 5 only here. You will get 5. You will get 5 here. You will get 5 there. Now coming to this here, s power 1. S power 1, what is the value here? Now for this, how? 16 into 2. This is plus you have to write. 16 into 2, that is 32. I will write directly. That is 32. 16 into 2, take plus, minus 1 into 5, take as minus, that is 5 only. 1 into 5, 5 by 16. Right? So 32 minus 5, it is 27 by 16. You will get, obviously it is 1.6 actually. You will get 1.6 or 1.68 otherwise correctly. So by your calculator, if you find out the value, you will get 1.68 here. And now what is the next value here? So in order to find out the next value, you ignore this particular column, go for the next one. Obviously must be 0 only. Then it is again 16 into 0, this value. So here the next value, if you calculate 16 into 0 minus 1 into 0, 16 into 0 is 0, 1 into 0 is 0, 0 minus 0 0, and finally we will get 0 only here. So only we will get here one value only, that is 1.68. Okay, so this I will write here. I will erase this. You will get, what is the value? 1.68. You will get 1.68 only there. Clear? 1.68. And finally, what is s power 0 value? What you will get here? Here obviously, here if you want, again the same, 1.68 into 5, 1.68 into 5 minus 16 into 0 by 1.68. Clear? 1.68 into 5 minus 16 into 0 is 0. 1.68 into 5 by 1.68. Therefore, 1.68 by 1.68 will be cancelled out. You will get 5 only here. You will get 5 only here. So this is what actually, though this is what Routh array. This is the simplification. So from the given characteristic equation, the Routh array will be formed like this. So with this, so your problem is over. Now you need to see the first column of this Routh array. Consider the first column. This is the first column of the Routh array. See that all are must be positive. The condition is that all the elements of the first column of the Routh array must be positive. That is one important condition to obtain the stability of the given characteristic equation. So all the elements of the first column, nothing but this one, this first column of the Routh array, this is overall called as Routh array. So the first column elements means 1, 1, 16, 1.68 into 5. See, any one is there, any negative is there, negative value? No, all are positive only. In fact, greater than 0. All are positive. 1 is positive, it is greater than 0. Again here 1 is positive, definitely it is greater than 0. It is 16, greater than 0. 1.68, greater than 0, 5. All are greater than 0 only. All are greater than 0 only. Therefore, simply you can say that the given system is a stable system. The given system is a stable system. That's it. That's it. That is what. Likewise, we have to comment on the stability of the system. Right? I think it is very simple example, okay, on this stability. Right? I think we will finish off with this example, this particular presentation, and we will see some more example in our subsequent presentations. Right? Thank you for watching. See you again in the next presentation. Have a nice day.